All right, guys, this is question number 6 from the 2018 BC exam. This is the Taylor question. And you're given that the ln of 1 plus x converges to this series here. And you're also told that f of x is equal to x times the ln of 1 plus x over 3. Part A, it says to write the first 4 non-zero terms of the general term for the Maclaurin series for f. Okay, so I did this one just a different way, just to show you could start with the general term if you wanted to. So that's what I did. I started with the general term. Okay, well, you know, if you look at this, what's happening is this guy right here is being multiplied by x, and then where you see an x, we've replaced it with an x over 3. So that's all that happened. So I took my general term in purple right here, and I said x times, okay, that's a copy job right there. And then where I saw this x, I replaced it with x over 3 and then copied the n. Okay, and then pushed it forward, jumped the x over just to make it sit next to the other x. So now I'm here. That n right there gets distributed to both pieces. So that puts me to here. Okay, and then my final step, well, that just copies along, that's fine. And then like this x is kind of like x over 1, right? So x times x to the n is x to the n plus 1. And then this 3 to the n, he comes downstairs and sits next to the n. So you've got n times 3 to the n. If you wanted to think about this piece differently, you could be like, that's n over 1, and then flip and multiply, and that's why the n's downstairs. Either way. So I got my general term first. And if you have that, to get your first 4 terms, then all you got to do is plug a 1, 2, 3, and 4 in for your n's right there. And that's what it spits out. Okay, so that's part A. Part B, it says to determine the interval of convergence for the Maclaurin series for f and show your work. Okay, so the best way to do this is to do the ratio test. And what happened here, it's like, remember with the ratio test, you do the next term over the current term. So in the next term would be like negative 1 to the n plus 2. Instead of negative 1 to the n plus 1, be negative 1 to the n plus 2. Well, I just went ahead and separated that out, right? Because I knew that was going to cross off. We've talked about that in class plenty of times. So that right there does say negative 1 to the n plus 2. Same thing here. That should be like an x to the n plus 2. I went ahead and just split it out because, again, like x to the n plus 1 times x is x to the n plus 2. And then everywhere I see an n, I'm putting an n plus 1, right? So like there's my n plus 1 happening. And then here, this is like 3 to the n plus 1. Same thing, right? I just went and peeled the 3 off. Like that does equal 3 to the n plus 1, okay? Multiplied by the reciprocal, right? It's like the next term divided by the current term. Well, you flip and multiply, and so there's your copy job right there. And then stuff just starts to cancel off. And then what you do is you take the limit as it approaches infinity of what's left over, and that puts me to here, right? Like those guys are of the same size, so they end up just kind of crossing off, okay? And you set whatever's left over in between negative 1 and positive 1, okay? Now, that's a negative sign right there. I don't want it to be negative, so I multiply the entire thing by negative 1, which flips those inequality signs, and if you reorder it, it puts you back to here. Okay, we've talked about that before also. And then multiply everybody by 3, and that gives you your preliminary answer because you got to check your endpoints, okay? So if I plug a negative 3 in, well, if I plug a negative 3 in, that guy right there is going to square to positive. He's going to become positive. That guy's going to square to positive. He's going to become positive. So it's like not alternating, which means that it's harmonic, or p is equal to 1. So you've got diverging happening. If you plug a 3 in, he stays positive, he stays negative, he stays positive, he stays negative. So it's alternating, which means that it's an alternating harmonic, which converges. So the equal to sign only belongs on the positive 3. That's my final answer. And then part C, let the 4th degree Taylor polynomial about x equals 0. Use the alternating series error bound to find the upper bound for p sub 4 of 2 minus f of 2. Okay, so you should just recognize that's the first neglected term. So just copied what they gave me, and that has to be less than or equal to the first neglected term. And like all that's happening, right, I'm just plugging a 2 in where I see x. Absolute value means the negative sign goes away, and then it reduces to 8 over 81. All right.